Great. Now let's create a bunch of more methods inside our DQN class. Now we have created the model. Now let's create a method to train the model. Train self, and then done, and then step. So we are going to train the model based on few conditions. So let me just write out few constants here. Mini batch, mini batch, mini batch size, mini batch size equal to 64. So that is, we will take a batch size of 64 every time we train the model. Great. And then I guess that's it. Okay, great. So we will, okay, and before this, we'll add another function, def update replay memory. So update replay memory, it takes in self, and then it takes in the transition, transition. So what this essentially will do is it will take the transition and append it to our replay memory, so that if the value of the replay memory has reached the memory size, I'll just rename this as replay memory size, REPLAY, replay memory size. So if the replay memory has, oops, okay, I have to rename this as well. So replay memory size. So what we are going to do is, so if the length of self dot replay memory is less than replay memory size, or okay, I'll add one more constant, which is minimum or min replay size, which will be let's just say 1000. These are all sort of hyperparameters which you can change. You can play around with that. So min replay size, if the length of the replay memory is lesser than the min replay size, then we're just going to say return. Great. Now let's just create one more variable, say mini batch equal to take from a random dot sample, then we'll pass in the replay self dot replay memory and the mini batch size. So what this does is it returns, so you can see what this essentially does is it takes in a population and returns a population of the length of batch size. So if you pass in, let's say, a list which contains 1 2 3 4 5, and you say the k value is 3, so this sample returns out a value which is 1 to anything between the length of 3. So let me just go ahead and show it to you what I'm actually talking about. Right, so I've created a list which contains a bunch of different values. It contains, sorry, not a list, it's a tuple. It contains a list, a number, and another list, and a boolean type. Right, so now I'll append it to this DQ, and DQ contains all the values. Right, now if I say random.sample and I'll pass this population along with, let's say, a k value of 3, so you can see it returns out a value from this transition with a length of 3. So, and this value is not constant, it keeps varying. So if I run it again, it returns something else. So that is what essentially the random function is doing. Right, so great. So now we have created the mini batch which returns a bunch of values from the replay memory. Great. Now let's get the current state. Now we are doing this if we already have the Q value set up, right? That's why we are doing this. Current state equal to np.array. Now what I'm going to say is I'm going to do some list comprehension. Now transition of 0 for transition in mini batch. So from the mini batch, iterate through all the values in the mini batch and return the zeroth value of the transition, and then convert it to an array and save it in the current state. So this is essentially our image, right? This is our image which will be used to where we'll create a model based on this, where we predict the Q values, and then current Q list or current Q val is equal to, we will predict it off of our model, self dot model dot predict on the current states. Now I think it makes more sense. So what we are doing here is we are passing the image and we are trying to predict the Q value for that particular image, right? Yeah, oops, and I almost forgot to normalize. So in machine learning we normalize the values. Now for all the more theory, you can check out my videos. Great. So now that we have created the states, different state, and the current Q value, I think we are good to go ahead and create the new Q state. So if you remember from our example of the previous tutorial, we had said we had created the Q value based on the formula, right? So let me just go ahead and show you that formula. Right, so we had created the Q values, the new Q state based on this Q value. Now here what essentially happens is, the part from here is being taken care by our model, and we should only account for these values, the reward, the discount factor, and the maximum Q value. Because if you think about it, our model is predicting not predicting, the model is accounting for all of these values, 1 minus learning rate and the old state, but we have to account for the remaining formula, right? So that is the reward, the discount factor, and the estimate. So how are we going to do that? So great, now let's just get back to where we left off. Right now, okay, now let's create a new new current state is equal to, it's again an np dot array of the transition, this time the third index for transition, trns transition in mini batch, and of course also uh, normalize this. Great, and then we'll predict the future q value. So future, if you ture, future q val equal to, now please uh, give your attention guys. So self dot target dot model dot predict. Now this is the key factor here. Right, so now if I go up, now you can see I've created two models, right? One is the self dot model and then one is the self dot target model. So what we are doing in the self dot model is we are essentially predicting for every given image. Where is that? Yeah, right. So you can see here, so self dot model dot predict. So we're essentially predicting for every given current image, right? So that will make the model go crazy when we are trying to predict for every given image, but we don't essentially want to do that, right? So we want to predict, if we have 100 images, maybe we want to take the average of, let's say, 50 images, and then predict based on those 50 images, right? So this model is for predicting for the essentially for all the images, but this is the actual the future q value which will be using to update the q table, right? So you can think of this is as a helper model which will try to predict, which will give us the prediction, but this is the actual model which will predict based on the given values. So this will predict the q value for the new current state. So that is what we want. Hope that makes sense. Remove the redundant parentheses. All right. Right. So if that is not the case, now we'll create x and y. X and y. Great. Now so for I or index, comma, a bunch of tuples, current states urr ent. Wow. I'm sorry for the theme I'm using. It just I can't see anything. Current state action reward new current state and then done. New current state and done in enumerate of mini batch, mini underscore batch. So our mini batch will return all of these values, right? So for all of that in our mini batch, what we want to do is, now if not done, that is we have not finished our goal, that is we have not reached our goal, we'll set max future, if you ture future q val equal to np dot max of the q of the future q val of the index. I guess makes sense, right? So we are trying to predict the maximum of the future q val, so that is we are trying to account for this, the future q val, so the maximum of that. Great. Okay, and then the new q val equal to reward plus discount. Okay, I think we haven't times the max future qval. So if you take a look at this, so that's reward times the discount factor plus the maximum future qval. So that's what we are trying to do. Okay, and then discount, we have not initialized discount, so let's say discount. If you can recollect from the previous tutorial, it's 0.95. Let's just confirm. Yeah, it's 0.95. Great. So far so good. Maybe we have to do the train. Oops. Oh, why am I doing this in this? This should be completely train. My bad. Right, so this is for the train and update. So we will just say self dot replay memory dot append the transition, and then yeah, that's it. So we are just updating the replay memory such that if the length of the replay memory is less than our min replay size, then we just return that off. We are not going to continue. Okay, makes sense. And then yeah, now let's just go ahead and create our x and y, the list of features and the prediction values. So we are trying to predict x. Sorry, we are trying to predict from the model, we are trying to get y based on the x. So given x, we want y. So um, x is the image that we pass, and y is the qval that we are trying to predict. Okay, great. If not done, okay, now we have all that, and now if done, that means we have complete, successfully rendered and made our the agent reach the target or reach the goal. So if that is the case, then we'll set the new qval to the reward itself, right? It makes sense, right? So we are not updating anything anymore because we have reached our goal. So we have just stopped it and we have set the reward to the new qval. So that is the latest qval. Okay, makes sense. Then inside the for loop, we're just going to say current 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 qval or current q values is equal to current qval of the index, right? So the current q value is equal to the current q value of the index. We are trying to get that, and then the current current q's of action is equal to new q value. Hope it makes sense. So if we have not reached the goal, we'll try to optimize the q value. If we have reached the goal, we will set the new q value to the reward, and then we'll get the current state and the action, and then set the action to the new q value. All right, and then we just have to append the x value and q value. So x dot append the current state, not the states, just the state. X dot append the current state, and y dot append the current q values or the current q's. All right. So now we have the x features and y dependent variable. So now we have the x vals and y vals, where we are trying to predict given x what is y. All right. Now the next thing is we have to fit our model. Now we have x and y. We just have to fit our model, right? So model, we call it history equal to a self dot model. You know what, we're not going to be taking any sort of we're not going to be doing anything after that. So fit, and then np dot array of the x, and then we'll have to obviously normalize it, and then np dot array of y. Of course, you don't need normalization, and batch size equal to mini batch size. All right, and then we'll set shuffle equal to false. And I don't think we will need any callbacks. All right, I think that's it. That's more than enough. Cool. So far so good. And now we say if done. If done, we will update the SCLF self dot target update counter to, we'll update it, so plus equal to 1. So we'll update it for every time it is done. That is, it is done with for every episode. All right, great. Now if what we are going to do is, if self dot target update counter is greater than, what we are going to do is, we will see if it is greater than, we don't want to fit every time, or set the weight of the model every time, right? It makes no sense. So we will update it for, let's say, let's say for every 5. All right, so if it is greater than 5, then we'll say self dot, we have to, target model dot set weights is equal to self dot model dot get weights. Makes sense, right? So we are setting our target model weights based on our actual model weights, and then reset the target counter to 0. Okay, so far so good. And we'll just create one last function which will just return to us the q values given the state. So this is where the actual prediction takes place. So given the state, we just want the q value. Okay, so self dot model dot predict. So we have to obviously convert the given state to the array dot array np dot array the state, and we have to reshape -1 times state dot shape. So that state dot shape returns, if it's a list, then it returns the list shape, right? So, and we are going to reshape and use that as the state to predict our q value. And then of course, if you're wondering, we have to normalize it, and we have to, if this thing returns a list, we just want the values inside the list, so we just return the 0th index. Okay, great. So if we look back, what we have done in this new Python file is, we have created a class, we have declared and initialized our class variables, and we have created few methods or functions. First one is the create model, which is essentially the architecture of our model. For more details, you can look up my video which explains this everything in details. Okay, great. And then we don't want so much space, we'll just take the off. Okay, great. So now next is, for every given transition, we just have to append to that replay memory, which is essentially a DQ of maximum replay memory size. Great. So this we are doing because we want to see if it is less than the min replay size. If it is less than the min replay size, then we have to populate enough to make sure that it is greater than the min replay size, and then we can go ahead with our training the model, because we essentially want to have at least a thousand replay size, so that we are at some position to get started off with the training at least. So even if we don't even have that to get started off, we can't do we can't sort of train the model, so to speak. Okay, and then mini batch is, it just returns a sample which takes the replay memory size. Great. And then this is the current state, and we are predicting the q value for that given state, which is essentially an array, and we are iterating through the mini batch, and for every for all the values you just want the 0th value of the mini batch, and we are normalizing that. Great. And then the new q value and the future q state, this is to account for our formula where we have to get the reward, discount factor, and the maximum q value for the future q value. Great. um all right, and then I think this is pretty much self-explanatory. So we get the maximum future value, and then we set that to the new q value. So this is our new q value. That is, I think this is a little bit. Yeah, I don't think we did. We use step. Yeah, not really. I don't think we needed step. Yeah, my bad. I don't even know why it got there. So step is not used. We're just gonna put. All right, I think that is pretty much it. And the next tutorial we'll learn. Yeah, sorry. Okay, so cool. So if not done, I'll take done, right? So if not done, that means we have still not finished our epoch. Sorry, the episode. Then we'll set the new future QL and get the discount. If it is done, then the reward is the new future, the new Q value. The reward is the new Q value because there is no more episode to carry on with. And then we get the current Q value or the current Qs, which we get it from the Q value, and the action we perform, we'll set that to the new Q value. Great. And then we are just going to append the current state, the current state, and y is the values, x values, sorry, the y values, which is just the q values to be predicted. Great. And then we just fit x and y, reshape it and fit with the batch size of 5000. Sorry, 50,000. No, sorry, with the batch size of 64. Sorry, the batch size of 64. Right. And then we set shuffle equal to false. Now, if done, so I think this is we will say if m done. Great. Now if m done, we'll update the target for every time. And then if the target is greater than 5, we'll set the weight to the target model, which we got from the actual model. And then we'll reset the counter because the every epoch, sorry, the episode after every 5 episodes, right? So we'll set it to 0 because we don't want to keep on populating after it. Okay, great. And then this function is pretty simple. This will just return the given the state. It will just predict what are the q values for that given state. Great. And the next tutorial will continue on creating the creating the agent, um, that is creating the object of the agent and iterating through multiple episodes. See you in the next, guys. Thank you.